Hey, Algebra 1, we are finishing up with Chapter 6 with this lesson. And then we have a test coming up, as you know, on Thursday before spring break. Let's get it over with so that when we come back, we can start fresh. We're going to be learning some special product patterns today. So let's take a look at the first pattern. The first pattern is called the square of a sum. Now, why would it be called that? Well, because we're going to be squaring something that has been added together. So when we see something that looks like this, where we're adding these two things and they are being squared, it fits into this pattern right here. A squared plus 2ab plus b squared. So let's see how this works. So if you take a look at what you have on your paper, this takes us through an entire example here where we're going to use the pattern. So notice that the first thing that was done was the pattern was written out. And you have to just memorize that. Now really, what can you do? A plus b squared means a plus b times another a plus b. So if you use what we learned in the last video, which is FOIL, that's where this comes from. First, outer, inner, last. We would have a squared plus ab plus another ab, that's why there's two ab's, and then plus b squared. So that's where the pattern comes from. So once you learn the pattern, memorize the pattern, whatever you have to do, now it's a matter of plugging things in. So what's in front of your plus sign is your a. So for our problem, it's this s. And everywhere that there was an a in the pattern, they have now replaced it with an S. Then what you see behind the plus sign, in this case the 5, is going to go in place of every time we have a B in the pattern. So right here where I'm highlighting in green, that's where we had a B in the pattern, and that's where we're plugging in the 5. And then once you do that, you're just simplifying it. So s to the second power is just s squared. Here, this is not the distributive property. This is just multiplying these three things together. 2 times s times 5 is a total of 10s. And then at the end, 5 to the second power turns into 25. You'll notice that none of these are like terms. If you use this pattern, when you plug it in, you don't have to worry about simplifying at the end because there won't be any like terms. So let's try this pattern out with example number 1. So remember I said what comes in front of the plus sign represents our A in the pattern, and what comes behind the plus sign represents the B. So first thing I'm going to do is write the pattern down, which is the a squared plus 2ab plus b squared. And now all I have to do is plug in my values for A and B. So when I get to the letter A, I'm going to plug in D. And then when I get to where B is in the pattern, that's where I'm going to plug in the 1. So all I've done is taken A out and replaced it with a D. I took B out and replaced it with a 1. And now I'm going to simplify. So D to the second power is D squared plus, in the middle, I'm just going to multiply those three things together. Again, it's not the distributive property. It is 2 times D times 1, which is just 2D, plus at the end we have 1 to the second power, which is 1. Notice it's already in the right order, descending order there. Also notice that there are no like terms, so you don't have to worry about doing anything else once you have it simplified. All right, let's do the same thing for number 2. Again, first thing I'm going to do is write down the pattern. So a squared plus 2ab plus b squared. When I get to the letter A, I'm going to replace it with a 2x. When I get to B, I'm going to replace it with a 3y. So I'm going to have parentheses, 2x, close parentheses, squared, plus 2 times 2x times 3y plus 3y squared. So again, all I've done is taken out the a and replaced all of the a's with a 2x. I took out the b's and replaced them all with a 3y. Now notice I put parentheses here. This is going to make the difference because when you square this, you're not just squaring the x, you're also squaring the 2. That's why it's important to put those parentheses there. So 2x raised to the second power is 4x squared. Remember, you have to take that exponent of 2 and it had to go to the 2 as well as to the x. Again, in the middle, this is not the distributive property. This is just multiplying straight across. I like to do my numbers first. 2 times 2 is 4. 4 times 3 is 12. And then we're multiplying by an x and a y. So I get 12xy in the middle, plus, for the last term, again, I'm squaring not just the y, but also the 3, and that gets me 9y squared. Again, look, no like terms, so you don't have to worry about combining like terms at the end. That answer is the final answer. All right, so the next pattern is very similar. It's called square of a difference. The only thing that has changed is instead of what's in the parentheses being addition, we now see what's in the parentheses as subtraction. But guess what? The pattern is almost identical. If your middle sign is a minus sign, then your middle sign is a minus sign. So if you've already memorized that first pattern, the only thing that's going to change is if the middle sign is a minus, then our middle sign here is also a minus. The front and the end, they're still positives. So you don't need to worry about that. It's just the one in the middle that's going to change. Again, we're going to identify what's in front of the minus sign is the A, what's behind the minus sign is the B. Don't keep the minus sign with the B. What's behind the minus sign is the B. The pattern takes care of the minus sign. So let's look at how it was performed in this next example. So we're using 3G in place of the A. We're using 8 in place of the B. Not a negative 8, just an 8. What's behind the minus sign is the B. So again, here is the pattern, a squared minus 2ab plus b squared. We're replacing the a's with 3g. We're replacing the b's with an 8. And then we're just simplifying. Again, notice, no like terms. It is already done. So let's jump into example number 3. Again, I'm going to start by writing the pattern. The pattern is a squared minus 2ab plus b squared. So what has come before the minus sign? That is going to represent your a. Lucky for us, it's also an a. What's after the minus sign is going to be the b. So everywhere we see a b, we're going to plug in a 4. So I have a, raising it to the second power, minus 2 times a times 4, plus 4 raised to the second power. So the first term is going to be a squared. Now the middle is a minus. Remember, if the middle inside the parentheses is a minus, then this middle term is a minus. 2 times a times 4. So it's minus 8a and then plus 4 squared, which is 16. Same idea for number 4. I'm going to plug in a 5g in place of the a. I'm going to plug in a 2h in place of the b. So again, I'm going to start by writing my pattern out. So I'm going to have 5g that we're going to square, minus 2 times 5g times 2h plus 2h that we're also going to square. So when we square this, it's not just the variable that's going to be squared, but also the coefficient. So that turns into 25g squared minus, remember this is multiplication, not the distributive property. I'm going to start with the numbers. 2 times 5 is 10. 10 times 2 is 20. And then I'm going to multiply the 20 times both a g and an h. Plus, again, that exponent of 2 has to go to everything inside of the parentheses. And so that turns into 4h squared. All right, so those two patterns were very similar. If you can remember one of them, then the other one is going to be a piece of cake to remember as well. This next pattern is one I want you to put a star beside. So I know that these are 3 patterns, and here's what I will say, that the first 2 patterns, if you forget them on the test, no big deal. Foil it out. It's easy. You can always revert back to foiling or the distributive property if you forget a pattern. Now, where these patterns are truly going to be helpful is when we get into chapter 7, which is why I would like for you to take the time to learn them now. But if you forget it for the test on Thursday, again, not a big deal. Foil it out or use the distributive property. But this next pattern right here is the one that's really going to be the most helpful as we get into chapter 7. So if you can only remember one pattern, this is the one to remember because it's going to be the one that's going to be the absolute most useful. And it is called difference of squares. The reason it's called difference of squares is because it's subtraction between 2 perfect squares. So we're subtracting 2 things that are squared. So you're going to be given a problem that looks like this. What I want you to notice is one of these has a plus sign and one of these has a minus sign. And it doesn't matter if your plus sign is in the front or in the back, but one of them has a plus and one of them has a minus. What's in front of the signs is the same. What's behind the signs is the same. And if that's true, then we get to use this pattern that we call difference of squares. So let's see how it works with this example right here, letter C. So again, notice one of these has a plus sign, one of them has a minus sign. What's in front of the plus and minus sign is the same. It's both a 4x. And what's behind them is the same. It's a 7. So according to the pattern, which is a squared minus b squared, the 4x is going to be your a because it's in the front of the parentheses. The 7 is going to be your b because it's at the end of the parentheses. Not a -7, just a 7. We're looking at what is behind either the plus or the minus sign. So we're plugging it into the pattern and we end up with 16x squared minus 49. This pattern is the most useful pattern, particularly when we get into chapter 7. So I am stressing to you that you need to learn this one. So let's look at number 5. According to the pattern, it's going to look like a squared minus b squared. Well, for a, this is where we're going to use the letter b because it's what's in the front of the parentheses. And in place of b, we're going to be plugging in a 2c because it's in the back of the parentheses. So I'm going to have parentheses b, close parentheses squared, minus parentheses 2c, close parentheses squared. So I'm plugging in my value for a, I'm plugging in my value for b, and now I just need to simplify. So b to the second power is just b to the second power, minus, now I'm going to take that exponent of 2, and it has to go to everything inside of the parentheses. So I'm going to get 4c squared. Again, no like terms that you have to worry about. That is what it is, and it is the final answer. Let's look at example number 6. What do you guys think we're going to plug in place of the a? So all I'm doing right now is writing my pattern. Hopefully you guys are thinking, hey, 6k is what we're going to plug in place of the a. What do you guys think we're going to plug in place of the b? Hopefully you have figured out that it is an 11. So 6k to the second power is 36k squared, and 11 to the second power is 121. So we end up with 36k squared minus 121. All right, why are these patterns useful? Well, let's go over them and just make sure we know them real quick before we get to the challenge problems. So for number 1, hopefully you recognize that that pattern is a squared plus 2ab plus b squared. What will we use for the a? We're going to plug in the 7y. What will we use for the b? We're going to plug in a 3. So all I've done so far is plug my values into the pattern, and now I'm going to simplify. 7y to the second power turns into 49y squared. Then in the middle, we're just multiplying. 2 times 7 is 14. 14 times 3 is 42, and I still have a y with it, so 42y plus 3 squared turns into 9. Done. Number 2, almost the same pattern. But what happens? We get a minus sign in the middle. Why? Because we have a minus sign in the middle. So in place of A, I'm going to plug in a 3M. And in place of B, I'm going to plug in an 8N. So all I've done so far is plugged everything right into the pattern, and now I'm going to simplify. 3m to the second power is 9m squared. Then I'm going to bring down my minus sign, multiply in the middle. 2 times 3 is 6. 6 times 8 is 48. And we also have the m and the n that are being multiplied together. Bring down the plus sign. 8n to the second power turns into 64n squared. Again, once you're done with that, that's it. Number 3, this is the difference of squares pattern. So this is your a squared minus b squared. We're going to plug in a 2b for the a, and we're going to plug in a 5 for the b. So our first term is going to be 4b to the second power minus our second term is 25. Same thing with number 4. Same pattern, a squared minus b squared. We're going to plug in a 6w for the a. We're going to plug in a 4z for the b. And now we're going to simplify. So 6w squared turns into 36w squared minus 4z squared becomes 16z squared. Again, that's your final answer. All right, why is this pattern or any of these patterns useful? Well, let's look at number 1 for our challenge problems. If you look at the problem, we have 3 different things that we're multiplying together. This in parentheses, another thing in parentheses, and then this last thing in parentheses. I'm going to start with the first 2, not necessarily because they're the first 2, but really because they fit one of those patterns that we learned about today. And that pattern is the difference of squares pattern, which is the a squared minus b squared. What will I use for a? I'm going to use the 3m. What will I use for b? I'm going to use the 2, which I totally wrote down the wrong number, so let me fix that. So 3m to the second power turns into 9m squared, and 2 to the second power turns into 4. Now we still have the m plus 7 that we haven't done anything with yet. But so far we used a pattern to multiply those first 2 together to make it quicker. Now, we do not have a pattern that we get to use for the rest of this problem, because although these have different signs, what's in front of the signs are not the same, and what's behind the signs are not the same. So we don't have a pattern to use. This is where we're going to use what we did yesterday, which I'm going to just write down, FOIL. So let's talk about first. First means I want to multiply the first term from each set of parentheses. So that's the 9m squared and the m. O stands for outer, so I want to multiply the 2 outermost terms. So that's going to be 9m squared times 7. I stands for inner. I want to multiply the 2 innermost terms. So that's a -4 and a positive m. And then last, I want to multiply the last term in each set of parentheses. So that's a -4 and a positive 7. So now let's do some multiplication. 9m squared times m. Remember that you're going to keep your base the same and you're going to add your exponents. So we get 9m to the third power plus, here we're going to multiply 9m squared times 7. That's going to give me a positive 63m squared. Next, I'm going to multiply -4 times m, which is -4m. And then last, I'm going to multiply -4 times 7, which is -28. You'll notice I don't have any like terms. It's already in descending order, and that's our final answer. Let's look at number 2. Hopefully you're thinking, what could you do? Now, if you look at it the way that it's currently written, if I were to multiply those first 2 together, there's no pattern that I could use. Same thing for the middle 2, same thing for the last 2. But what if we use the commutative property and we change the order that we multiplied in? So I'm going to take the k minus 2 and I'm going to move it in front of the k minus 5. And you might be asking yourself, why am I doing that? Well, if I do that, these two could use the difference of squares pattern, and these two could also use the difference of squares pattern. And that's exactly what I'm going to do because I think that's going to be faster. So according to my pattern, for the first two anyway over here, I'm going to do k squared minus 2 squared. And what does that turn into? It turns into k squared minus 4. So that's the multiplication of the first two. Now I'm going to come over here and do the same thing. Again, I'm using the difference of squares pattern. So I'm going to have k squared minus 5 squared, which turns into k squared minus 25. Now I have these two things left, and I don't have a pattern that's going to go with it. So this is going to go back to yesterday's lesson of FOIL. So first, I would do k squared times k squared, which is going to be k to the 4th power. Remember, you keep the base and you add the exponents. Then I'm going to do outer. So k squared times negative 25 is negative 25k squared. Then we're going to do inner. So negative 4 times k squared is negative 4k squared. And then we're going to do last. Negative 4 times negative 25 is positive 100. It's almost done, but I do have like terms. Those two in the middle, they both have k squareds. So I'm going to keep the k to the 4th power, but now in the middle, negative 25k squared minus 4k squared turns into negative 29k squared. And then I'm going to keep the 100 at the end. So at this point, I have no like terms, and it's in descending order. So just as a reminder here, I would love for you guys to learn all three of these patterns, but if you feel like you can only learn one of them this week, then the one I want you to learn is the difference of squares. The other ones you can FOIL out. If you forget the pattern, no big deal, but the difference of squares pattern is really going to be the one that helps you out in chapter 7. So if you can only remember one, that's the one I want you to focus on. So you guys have a homework assignment. I'm pretty sure it's in the book. We are going to be doing practice work to review for your test for Thursday. So as you are coming to problems that maybe you're struggling with, let me know. Email me, whatever. As far as this week goes, we have planned a Zoom session, obviously on Thursday for the test. And I think we were also going to have one on Wednesday to do some practice. So be prepared with questions. You guys have the Chapter 6 test review. Be working on that. Ideally, you need to go ahead and look at it before we meet together in our Zoom session on Wednesday so that you can have questions ready. Because as you know, the Zoom sessions are only for 40 minutes. So once the time runs out, time runs out. So let me know what you're struggling with. Send me an email, something, communicate with me somehow. And let's keep up with our work and really finish strong before spring break so that you guys can have an enjoyable spring break and not be so stressed with math. Okay? I'll see you guys in our Zoom session tomorrow. Bye.